All right, back in the game. Don't need that. And we're done with this. All right, so without further ado, we'll get on with the show we've all been waiting for. All right, so here's our map check. Here we are today. Today, we're going to focus specifically on population proportion hypothesis testing. Okay. I've broken this into 3 chunks. I'm going to talk much more about that, but today we want to think about PPOP. We want to have PPOP on the brain and what a population is, or what a population proportion is. We'll go much more into that. The big highlight coming up, there's no Pearson due this weekend or anything like that. Really want you to focus on putting your best effort forth on the Way of the Warrior project. And that'll be due on this coming Tuesday, no later than 7:00 p.m. It's never too late. So if you want me to look at your stuff before I assess it, I'm willing to do that. Time is kind of running out, and I have some other folks that are kind of in the queue. But hey, if you send it to me, I'll get to it, even if it's the night prior, okay, and give you some feedback. I always, whenever I get these things, I take an initial look. I kind of see, how quickly I need to get back to this person or people, and then I go from there. So if you want me to look at your stuff before I formally assess it, I am more than happy and eager to do that. I just need you to get it to me. Okay, moving on, looking at next week. So Tuesday of next week and Thursday of next week, we will Zoom again. I didn't put that in the remarks block. But we're going to focus on population means all next week. On Tuesday, we're going to focus on a situation where the standard deviation is known about the population. And then Thursday will be the opposite, where we don't know what the standard deviation is. And so we have to use our old friend, the t-distribution. So that'll take us through next week. Sometime in the next 24 hours, so probably early tomorrow morning, I will post some Pearson work that'll be due not this Sunday, but the following Sunday. And the point of that will be for you to get some reps in on all these hypothesis tests. Okay? Someone out there, if you could just check, everybody check and make sure you've muted your mic, because I love hearing all of you, but I can hear somebody kind of moving around and stuff like that. So just give that a double check. So that's our map check. Going on to our agenda for tonight. We're recording already, so that's happening. I want to talk briefly about all possibilities of hypothesis tests that at least we're going to look at in this course. And the purpose for that is so that you kind of have this hit list that you can use throughout the next several weeks to assess yourself. It'll make more sense in a minute. And along the way, we're really going to get into 2 different methods that get after the same outcome, which is whether we reject or fail to reject that null hypothesis. And that is the critical value method and the p-value method. So we'll get into those tonight. And along the way, we're going to do population proportion hypothesis tests. So any questions about anything, big or small, so far? All right. Everybody seems all worried up, if there is such a thing. And there is, in my opinion, and ready to go. I just want to do one thing real quick. Okay. So when we talk about the hypothesis tests that we're going to cover in this course, kind of like forest in the trees last time, it's a different forest and some different trees. But I put these into 3 big buckets. And I would make the analogy, this is kind of like going to Disneyland, or maybe not as fun. but we go or to the mall or wherever, some big water park. We go to this big place and it seems kind of overwhelming. And the reason I'm doing this is to try to make it not so overwhelming. Tonight, we're going to spend time in the population proportion types of hypothesis tests. And the thing is, there's really only 4 ways we can do that. It's the same question. Well, we can alter it slightly, but we can ask the same question and solve it twice, and then alter it and solve it 2 more times. Okay, but it's still mainly the same question. So that's 4 different types of problems that I could ask you right there that we're going to cover tonight. And then another big force is the population mean when we know the standard deviation. And again, that'll kind of come down to 4 different types, ways we could prosecute that problem. And then situations where we don't know the standard deviation. And that boils down to 4 more. So really, I know 12 is a bigger number than 6, and obviously is a bigger number than 0, but it's not 1200. Okay. And the other thing about this slide, and oh, by the way, all these slides, everything you're looking at tonight is on your canvas right now. And I will add more to it after tonight. But the point of this kind of slide is so that you can look at this in the coming weeks and say, how good do I feel about this force right here in terms of being able to recognize and solve a problem? Do I feel good? Do I feel bad? Do I need some more reps there? That kind of assessment that you can do. And then you can do something with that assessment. Do more reps, talk to me, talk to a fellow warrior, et cetera, et cetera. So that's why I create this, to kind of make this crazy amusement park seem a little bit more manageable. And also, it's important for you to know kind of where we're at, who's who in the zoo kind of thing. I'll show this slide 2 more times, at least. I'll show it on Tuesday. On Tuesday, this middle block will be highlighted, and I'll show it a week from now, and this bottom block will be highlighted. So you'll see this a couple more times. And if it's redundant, in my mind, that's okay. It's all about getting you comfortable, getting you confident, getting you proficient. Now, just take a deep breath and let's look at this next slide. This next slide is this slide expanded. Okay, so just to talk briefly about it, and don't worry about all of this needing to make sense tonight. It won't. Much more of it will make sense at the end of tonight. But I just want to show you the big picture. Here's where we're going to spend time tonight, up in Peepop land. And the beauty of Peepop land, that is population proportion hypotheses, is that we're always rolling with the Z distribution. We don't have to worry about the T distribution. We're always dealing with Z. And that makes things a little bit simpler. Once we recognize we're up here, we don't need to worry about the T distribution. We can either have a 2-tailed problem or a 1-tailed problem. We're going to go through both tonight. And we could, within those problems, there's 2 ways of doing each problem. Now, you're probably going critical value. I haven't heard of this. P-value, I haven't heard of this. You're right. We haven't talked about it yet. We're going to talk about it tonight. Okay? So, if this is, well, it's just too much for me, don't worry about it. Okay? Know where it is. Know that you can look at it later and back out of the trees, back into the big forest. Okay, I'm good with this. I understand this for now. Okay, so with that, we are going to jump right in it. Before we do, I'm sorry. I just want to talk about this dude right here. So this is a Word document that I wrote. I posted on Tuesday's Canvas. It's on your Canvas today. It's barely like page and a half. Okay. And I wrote it. That doesn't necessarily mean anything good or bad, but so you know, it's for me. And it was just my attempt to put the purpose of hypothesis testing into just plain English with an example that might resonate with you. So, regardless of how you feel about hypothesis testing, I would really recommend you take a look at this. Okay. And I welcome your feedback. If this really helped you, super. If this just made you hate the word hypothesis, well, let me know that too. And then I won't share it with people anymore. Okay. But this is there for you. And it's under the section today on Canvas, under today's page, that says tools to collect and organize. Again, tools are only as good as your ability to get to them when you need to in the fight. So there's that. Enough said on that. I just wanted to visually show that to you. All right. Let's see. And away we go. All right. So we're going to start off with, I call this 4-pack 1, because you're going to have 3 4-packs, meaning that you're going to have 3 packs of 4 problems that are just about the same problem done 4 different ways. Okay. And the purpose of that 4 different ways is for you to listen to me, for you to get reps in a very comfortable, repetitive setting. Like I said, at the risk of sounding like a broken record, D3M is built on repetition. We have to appreciate that. And there's so much strength in repetition. So, onto proportions specifically. So when I think of a proportion, and proportions hang up a lot of people, a lot of warriors get hung up on proportions. One way I like to think about it is I like to think about a pizza, because I just like pizza and it gives me an excuse to think about pizza. Pizza doesn't necessarily like me, but that's another story. So when we look at the pizza here in this picture, we can see that a piece is missing. So it doesn't take long for us to count and say, okay, there's 6 pieces here. That means there must be 5 there. And so there's 11 out of 12 pieces present. Well, that is a proportion. Okay. Notice how 11 divided by 12 is less than 1. To have 1, we'd have to have the whole pizza there. So what is my point? Point is that when we see proportions, we should be looking for decimals or things that we could easily turn into decimals. Now, that's not a hard and fast rule every single time. We might have a mean in the form of a decimal. For example, some kind of IT system or some kind of small screw that we're talking about diameters with, and you guys have seen Pearson do this, or widths of bottles and things like that, where we have a problem that says the mean is 0.456. Yes, that's less than 1. But we shouldn't be seeing the reverse. And here's what I'm talking about. We might see a mean that's 0.456, but we shouldn't see a proportion that's like 1,500. That's not a proportion. We have to do something to that 1,500 in order to make it a proportion. There's no such thing as 1,500%, okay? And at least not in this context. And, you know, it just, we can't say 1,500 in itself is the proportion. So at the risk of beating a dead horse, think that the most value a proportion could be is 100% or 1. And I would question how often a proportion is 100%. If I ask all of you, how many of you like my picture here? There'll probably be one of you that says, I don't. And that's okay. All right. But even then, it wasn't 100%. All right. That answer would be something like, I don't know, 17 out of 18 like my picture, or 5 out of 18 like my picture, or something. You see the idea? That's what a proportion, that's what makes a proportion. Okay. So just another tool. Hopefully that helps you visualize and recognize proportions in general. All right, here's what we're about to do. Here's our hit list for tonight. We're going to do these 4 things, and we're just going to take it very slow and deliberate and ask questions along the way and so on and so forth. All right. So to start out with our problem, okay, first of all, I'm just going to let the cat out of the bag. This is a population proportion problem up there at the top. It is a two-tailed test, and we're going to use the critical value method. Now, obviously on a test, I'm not going to give you that little banner up top. You're going to have to figure out those things. All right. Some of them I might tell you, like, I want you to solve this with the critical value method, but you're going to have to figure out if it's two-tailed. You're going to have to figure out if it's a population proportion. And all of you are very capable of doing that. So let me fire up my pen, get rid of all that. Okay. So according to a 2020 survey, and let's just say this was like at the beginning of 2020. Okay, obviously we're still in 2020, but let's say it's like 8 months old. 45% of US workers stated that they work during non-business hours. Okay, so like John Wick, who runs around at night and does all this crazy stuff, or maybe not, but just non-business hours. So as an entrepreneur looking for a market of non-traditional workers, you, meaning you, have decided to conduct a new survey to see if this proportion has changed. You notice that it didn't say that you believe or you want to see if this proportion has increased or decreased. Okay, just changed. That means it could increase, it could decrease, but you're not being specific. And that right there is your tip off that this is a two-tailed test. Two-tailed is kind of another way of saying, hey, it could go either way. Okay. So let's look at our results. The results of our new survey, 208 out of 400 US workers reported they work during non-business hours. You decide to use a 0.05 level of significance, also known as the artist formerly known as the little fish alpha. So here's the cool thing about these slides, but just period, is that we have steps. So again, we take a kind of intimidating thing like hypothesis testing, but we have a very clean framework to put it in, and we have steps that all we have to do is follow these steps. And as long as we know what we're doing, we'll get to the gold at the end of the rainbow. So the first step is to state the null and alternative hypothesis. All right. So Connor, pick one, either the null or the alternative, and tell me what you think it is.
Would the alternative be that the P-pop is not equal to 45%?
Okay, very good. And I'm just going to go with 0.45. But Connor is right. You all could use 45%. Okay. And Connor employed a tip that I think that I saw that you all collectively evolved, which I have since tried to adopt, which Connor said, okay, it's easier for me to develop the alternative first. All right. And hey, whatever way works for you, as long as you understand what you're doing. Now, Lauren, why don't you give the null a shot? What would that be?
Proportion does equal 0.45.
Very good. Okay, so nice, clean setup. Notice again the patterns. If we're using 0.45 in the null, we have to use 0.45 in the alternative. Some people kind of get ahead of themselves and they come up with a value that, well, I don't think it's 0.45. I think it's really something else. That really has very little to do with this right here. Okay, so you got to make sure these match and these match. Okay, and then these are the opposite. It either is equal to or it isn't. And this right here, this symbology, that characterizes the two-tailed test. Okay? When it comes to a two-tailed test, you will never see any other symbology other than equals to or does not equal in a two-tailed test. Okay? You can set your watch by that. So that is cool. All right, so we're done with step 1. Let's go to step 2. And I apologize. I'm not going to write step 1, step 2, because I'm going to run out of room anyway. But you can. All right, just so as long as you know where we're at. Choose the level of significance and the sample size. Well, you really don't have much choice because I've given it to you. The alpha is 0.05. Okay, and that alpha is the same thing as level of significance. Okay, so Ryan Matoza, what do you think N is?
Would that be the 400?
Very good. Okay, and while we're here, I mean, we don't want to get sidetracked, but we know that 208 is X. Okay, and we don't want to lose our eyes on the prize, but we could do a little math right here. 208 is the number of people that said in the survey that they work during non-business hours. We divide that by 400, and that's going to equal 0.52. That's actually X over N, which is equal to sample proportion P. But again, we just kind of knocked that out. Let's stay on track. We're kind of deviating from the steps, so I apologize. Step 2 is complete. We identified alpha and sample size. All right, cool. So we're continuing just slow and low. That is the tempo into this. Let's go to step 3. Determine the appropriate test statistic and sampling distribution. Like, golly, this sounds like a lot of words. I thought you said this was simple. It is. Let's do the distribution first. We have 2 distributions, Z and T. With P-pop, we're always rolling with the Z distribution. I don't have a catchy little phrase other than that one. But just think P is Z, P is Z, P is Z. They're not the same thing. That's not what I mean. But we don't have a choice of the T distribution. We're only going to roll with the Z distribution. And when I say the Z distribution, I mean our handy dandy Z table that we sleep with underneath our pillow and all that good stuff. I don't really. But so now the statistic, all right? This actually is a formula that's familiar to us. We're just going to call it the Z stat. And I'm not making up that name, but it's an old friendly formula. And that is the sample P minus the proportion of the population over the square root of the proportion of the population times 1 minus the proportion of the population over the sample size. We've seen that formula before. We used it when we're conducting sample proportions, and now we're going to use it again. But just remember what it is this time. It's a Z statistic. So it's kind of a Z score, and we don't need to spend too much time here. But you kind of got to know when we're going to use it like a Z-score and when we're not. And we're going to talk about that here in a second. So step number 3, we've determined the test statistic. We're going to use a Z-stat because we're rolling with the Z. And this is very simple. When we eventually use the T distribution, we're going to use something called a T-stat. All right? So if we have T over here and we have Z stat over here, that's kind of like, I don't know, playing tennis with a basketball. That just doesn't work. Okay. It's not going to work. All right, so we match up. So that's step number 3. All right, let's talk about step number 4. Determine the critical value, the rejection, and the non-rejection regions. Again, this sounds really complicated. Let's break it down a lot simpler. So we're going to draw this thing. And somewhere in the middle here is our P-pop. And what we're going to do is we're going to say, we're going to draw a line out here. We're going to draw a line out here. And we're going to establish these shaded areas as areas of rejection. Now, I don't mean like all those girls who I asked out in high school who didn't go out with me. That's not what I'm talking about. Or the fact that I didn't get into West Point even though I applied. I'm not talking about that type of rejection. I'm talking about rejecting the null hypothesis. Okay? So this is going to be a rejection region. And this is going to be a rejection region. Now, here in the middle is a do not reject region. So this is how this is going to work. We're going to put values into this TZ statistic. We're going to get a value. All right. Then we're going to see where that value falls. If it falls out here, we're going to reject the null hypothesis. If it falls out here, we're going to reject the null hypothesis. If it falls in this white space, we're not going to reject the null hypothesis. Now, how do we determine these critical values? That hash mark that helps us define the rejection region both here and here. Well, like many good things, we have a hack for that. So I'm going to get out of here and I'm going to go to my Z hacks for the hype. This is another slide that's on your canvas tonight under the section tools to collect and organize. So we're going to pull out our hack table. Notice how it says Z hacks because we're not going to use this with T distribution problems. We're going to go, do I have a two-tailed test or a one-tailed test? We have a two-tailed test. What is my alpha value, my level of significance? My alpha value is 0.05. That was given to me. So my critical values are going to be negative 1.6 and positive 1.6. Okay? So remember that before we go back to our other slide, and I'll show you where those values go and what we're going to do with those. Now, always, in the spirit of Ice Cube, we want to check ourselves before something bad happens. We got to remember we only use these tables under 2 conditions. Number 1, if we're doing hypothesis tests with population proportions, which we are tonight, so good to go. But if we weren't, if sigma is known, we're doing population mean hypothesis testing. So that's why I put this on the bottom here. If sigma is unknown, you can't use these hacks. You have no business using these hacks. Okay, so just so you know, again, like any tool, you got to know when you can use it and when you can't. So we're going to take that 1.96, both positive and negative. We're going to go back here, get my pen fired back up. Boom. All right. And that 1.96 is going to go right here and form that cutoff. And that negative 1.96 is going to form that cutoff. Now, Pearson calls this a decision rule. So I'm not trying to make things more complicated. The decision rule says reject the null. I'm just going to put RR. It doesn't stand for reject the null. It stands for reject if the Z-stat, which is this value we're about to figure out, is greater than 1.96, or if the Z-stat is less than negative 1.96. Okay, and all we're doing there is putting words to this. So if Pearson asks you decision rules, then just know how to interpret this diagram. And heck, I mean, I don't care so much if you can draw this diagram or if you just write the decision rules. So as long as you understand how to use these critical values, that's what's most important and what you're using them for. Okay. So for this up here, I am going to erase this and put the numbers in here. And while I'm doing that, just as another thing you'll have tonight is I have my notes for these problems. So you'll get a nice clean copy on Canvas with the correct computations so that you can make sure in case you miss something tonight, you've got that as well. So I lead in my numerator with little p, sample p. That's 0.52. I'm going to subtract the proportion, population proportion, 0.45. And then everything I do in the denominator is going to deal with that 0.45. 0.45 times 1 minus 0.45 all over 400. Okay, and once I put that in there and consult with the chicken, the answer I get is 2.814. So what? Well, I take that number and I look either over here on my rejection region or I look down here at my decision rules. So that actually is all step number 5. And here we are at step number 6, which is make the quote statistical decision, which is reject or do not reject the null hypothesis. So Jenna, based on the fact that my test statistic is 2.814, do I reject or fail to reject the null hypothesis? What do you think?
You would reject it because it's greater than 1.96.
Okay, outstanding. Very simple. And that is step number 6. Now, Colin, what's the so what of all that? That's step number 7 that I've added. So we reject the null, so what do we do now?
Well, so we know that's not true up top, right?
Yeah.
Mm.
Yeah, we've found that something else is going on. So the short of it is that, well, if we're an entrepreneur looking for a market of non-traditional workers, we're probably onto something.
Yeah, you'll probably have enough.
Yeah. Maybe we should, invest in marketing and trying to get these non-traditional workers. Now, the conceptual part of things, we'll go more deeper in that. Here's where a two-tail kind of fails us. And I'm not going to go into too much theory, though, because we know this test statistic is much larger than that. We know that probably the population proportion has shifted to the right and is probably like more somewhere out here. Okay. So that whole distribution has shifted to the right. That's theoretically what's going on with this kind of test statistic. All right. But the more I think about two-tailed hypotheses versus one-tailed, they seem kind of lesser value, because most of the time we want to know if something's increased or decreased, not just changed. You know what I mean? Anyway, we'll keep going. Any questions about what we've done on the board here so far? Big or small?
Yeah, I have a question.
Yep. What's up, Nick?
So does that mean that the alternative hypothesis is true?
No. It means we rejected the null.
Okay.
All right. So we never prove the alternative hypothesis. We either reject the null or fail to reject it.
All right.
Okay. And this is something that you're probably going, what's the difference? Well, it's kind of like saying, I don't know. I think Travis stole my soccer ball. So either Travis is innocent or he's not innocent, but I'm not proving him guilty. And I know that's probably not a very clear example, and it's probably even more confusing. But so we either reject the null hypothesis or we fail to reject the null hypothesis. Now, when we do reject the null hypothesis, this is what I call, it opens the door for us to conduct further investigation. Okay. But let's say that in order to do this right here, to get more money for a marketing campaign, I had sponsors, right? Let's say I was on Shark Tank. My son's like into Shark Tank lately, and he's watched like, I don't know, seems like 50 episodes. They're all the same to me. So we go into the sharks and they say, what was the result of your hypothesis test? And we say, well, we failed to reject the null. They'd be like, well, why should I give you more money? You see what I mean? Because but if we said, hey, we rejected the null hypothesis, so we think the proportion of non-traditional workers has grown, we might get that money. Okay. All right. So we'll just keep going. Let's wipe the slate. And okay. So here we're going to do the problem again. We're going to do it with what's called the p-value method. And the beauty of this is a lot is the same. Okay. So let's go down to our checklist. First of all, our narrative is the same. Our narrative up here has not changed one bit. Okay. So it's still a two-tailed test. So we're going to go down, but the difference is we're going to do the p-value method. Now, someone asked me in my other section, how will I know when to do the p-value method or not? I'm going to tell you, hey, I would like you to do this with the p-value method. You might go, well, could I choose on the exam? I would put it this way. Be ready to do any one of those 12 situations, recognize it, and do it. Okay. And then you won't have to worry about all that. In reality, what is preferred in academic circles and research circles, I've seen p-value used most of the time. I can't remember a time when I saw a critical value method. But that doesn't mean the critical value method is not important. And then finally, one of the most important things, notice that this is the same problem. We're just doing the test by a different method. So Cameron, do you think we're going to reject this one or fail to reject? Just take a guess.
I think we're going to reject it again.
Right. Why do you think that?
It's the same problem, just a different way to get to the same answer.
Exactly. Okay. So it's just a different way to skin the cat, but it's the same cat. I got nothing against cats. Terrible analogy. All right. So Let's go to our little checklist, state the null and alternative hypothesis. Well, it's the same. Again, P-pop is equal to 0.45. And then the alternative would be that it is not. Okay. And again, we might have a belief that it's really 60% or 70%. That really has no place in our hypothesis test. When we bring that in, we bring in bias. So we really can't do that. Okay, so that's step one. Step two, choose the level of significance and the sample size. Well, that hasn't changed. So again, our alpha, our level of significance is 0.05. Our sample size is n, the amount of folks we talked to. Okay? Determine the appropriate test statistic and sampling distribution. Because we're rolling with P-pop, we're rolling with the Z distribution. That hasn't changed either. The test statistic hasn't changed either. So Z-stat is sample P minus P-pop over all that. And I don't know, I'm old school. I guess the current phrase for that is boomer, but I just firmly believe the more you write things, it's not about memorizing, the more they become you. And so, yeah, it doesn't mean you shouldn't refer to a formula sheet. I still look in the book and look things up, but you definitely become more versatile and know what you are looking for. Okay, so that was step number 3. Let's look at step number 4. Collect the sample data, compute the value of the test statistic, and compute the p-value. Okay, that's kind of like that Rodney Dangerfield movie, Back to School. That was a lot of stuff in one step. Well, let's break it down. Collect the sample data. Well, we have half of it right here. We know that P, again, is that X divided by N, 208 divided by 400. And so that equals 0.52. Okay, so in this event, that's our sample data. There's nothing else to collect. Okay, compute the value of the test statistic. All right, our test statistic is not going to change. We're going to put that in there for P. We're going to put 0.545 in there for P-pop, and we're going to put 400 for N. So our test statistic is still going to be 2.814. That's what this equals. Now, compute our p-value. This actually sounds more difficult than it is. It's not that difficult, but there is a trick to it. Okay, so that's where, in this regard, we can look up this. There's a couple different ways we could do this. We could look it up on the Z table, our friendly neighborhood Z table, and see what 2.81 refers to. And that is going to be 0.9975. Okay, let me back up one bit. Again, we draw our picture and we're talking about this area here. Okay, is what that's going to refer to. So this, remember what a z-stat and a z-score is. It tells us the same thing, how many standard deviations we are away. 2.8, that's pretty far out there. But we got to do a 1 minus with this. Okay, and once we do a 1 minus with that, we get this value right here. Okay, Or if you're like Matt likes to do the norm s dist XL function, and you can do the same thing. I'm just going to write that down here. And you can put 2.814 in there. You want to do true. You're still going to get this number right there, and you're still going to need to do a 1 minus. We're not done yet, though. Here's the part where you got to remember. If you are doing a two-tailed test, you have to multiply this number, once you've done a 1 minus, by 2. That 2 is for two tails. So we're also talking about a tail over here. And that will give you 0.005. Okay? So that is our p-value. Okay? Very, very important to multiply by 2. So that's our p-value. Now the question is, what do we do with it? Well, that's involved in step 5. And there's a couple ways you can remember what to do with that. One is this way that I think some dudes in white lab coats thought this was really cool. They're probably sitting around in the lab and like came up with this late at night. If the p-value is low, the null must go. You're kind of going, okay, what does that even mean? Well, we need to take this level of significance. Let's just line it up right here. Like that. And I'm going to put it underneath alpha. And then I'm going to put my p-value over here, 0.005. So what this, if the p-value is low, the null must go, what that means is that if the p-value is less than alpha, then you will reject the null hypothesis. I'll say that again. If the p-value is less than alpha, you will reject the null hypothesis. If it isn't, you won't. Essentially, it's another decision rule, if you want to put it that way. So the phrase really should say, if the p-value is lower than the level of significance, then reject the null. Now, here's another way by a warrior named Darby Hetrick. She goes, well, I just see if the alligator eats the fish. And I was like, Darby, what are you talking about? Well, if this number is greater than that one, then I'm going to put a greater than sign there. And man, that looks like an alligator about to eat that fish. So if the alligator eats the fish, you reject the null hypothesis. Boom. I was like, Darby, that's beautiful. So I have like a slide down here that's on your canvas tonight. Oh, no. Do I have it open? There it is. Shoom. If the alligator eats the fish, reject the null already. Because alpha kind of looks like a fish. So if the p-value is less than alpha, the alligator is going to go for the bigger one. Just make sure you know the difference between an alligator and a crocodile. One like sees you later, and anyway, little meme there. Okay. So back on track. Get all this stuff out of the way and get my stuff back up. Boom. So lots going on. Let's recap. Two-tailed test, p-value method. Everything was the same up until this determining the p-value thing. Okay, how do we determine the p-value? Well, we're going to take that test statistic. We're either going to use an Excel function or we're going to go to the Z table, but we got to know what we're looking for, okay, and figure out one of those tails. All right. In this case, because the Z statistic is so far out here, if we go to the Z table, we got to do 1 minus. There's no way around it. But once we get that p-value on a two-tailed test, we have to multiply it by 2, hence the 2 tails. Then we're going to take that p-value and compare it to the level of significance. Got to be able to say it to do it. Now, if the p-value was greater, so let's say this was like 0.26, we are not going to reject the null hypothesis. We're going to fail to reject it. Okay? So, any questions on this method? I know there's a lot going on. Again, the beauty of this is follow the steps. So, when you do Pearson, and again, I don't want to overload you. I know you've got the Way of the Warrior project. You're focusing on that. When you get around to doing reps, don't go into the gym without your checklist there. And for those first few reps, do it deliberately like I am doing it. Then once you get proficiency and maybe after a while, you don't have to look at the checklist. Me, I'm like, the checklist is there, so why shouldn't I look at it? You know what I mean? Especially I don't want to make a mistake. So there's that. All right, one tail. Fire up my pen again. So the only thing that has changed about my problem are these 2 words right here. Has increased. So let me reread the phrase. As an entrepreneur looking for a market of non-traditional workers, you have decided to conduct a new survey to see if this proportion, 0.45, has increased. So, Alexis, let's start down here on our checklist. Surprise, surprise. First thing we do, state the null or alternative hypothesis. So, Alexis, pick one. It doesn't matter whether it's null or alternative, either one that you want to go for. What do you think it is?
I'll do the null hypothesis.
Okay.
I'm gonna say it's has increased. Do I say it's less than 0.545
Like that?
or greater than 0.5?
You tell me. You want me to change this?
S to greater than.
Okay. Actually, you are correct. Okay. Because this is saying that it hasn't increased.
I am correct. Okay.
We're just missing one thing here. Delaney, what are we missing with this null hypothesis?
There should be an underline under the less than sign.
Yep. Also known as or equal to. Okay. So Chastity, what do you think the alternative hypothesis would be?
Would it be greater than or equal to?
Okay. So I'm going to do that there. What am I going to put over here?
45 or 0.45, sorry.
Okay. All right. And it's just greater than.
Okay.
And the reason is for everyone is because this is one of those few times in life we can say never. Never. We will never have an equal sign with the alternative hypothesis. Never. Remember, with the two-tail, we have a not equal to. And here, we do not have an equal sign in the alternative hypothesis. Conversely, we will always have an equal sign with the null, whether it's less than, greater than, or equal to, or just straight up equal. Okay, so this is kind of a moving tattoo kind of thing. I don't even know what the name of that is, but just remember that these numbers should be the same. These symbols should be the same. If you're talking about a one tail, the trickiest part is figuring out which way the tail goes. But no matter what, you should have, as Delaney says, an underline up here for that null hypothesis. Okay? And then the trick is just getting the alligator to face the right way. Okay, so here's our setup for the one tail. Let me get rid of these dudes. All right, moving along to step number 2. That sounds familiar. Choose the level of significance, alpha, and sample size. Well, by now, we know level of significance 0.05, sample size 400. All right, cool. On to step number 3. Determine the appropriate test statistic and sampling distribution. Again, if I sound like a broken record, that means that you're getting it. All right, so I don't feel bad about being like a broken record unless you're out on Jackson Street saying Dr. Shatzkin sounds like a broken record, but you're not going to be out there anyway unless you do it virtually. That would be interesting. So we're rolling with the Z because we're rolling with P-pop. And we know our friendly neighborhood Z stat. Once again, that is the incredible RAM animal. P minus P-pop over the square root of all that in a bag of potato chips that are down at Rutter's, but I'm not going there. Okay, so we have that. Number 4, determine the critical value, rejection, and non-rejection regions. Okay, so back in black, I hit the sack. Now, this time, because it's a one tail, I'm only going to have a rejection region on one side. Okay. And the tip off is where I'm focused at right here. So with the alternative hypothesis, where the greater than or less than sign, actually it's really which sign the P-pop in this case is on. Okay, we're saying it's greater than. So I want to be, remember, P-pop as we know it is here, and to say this would be to say this, that P-pop is really out here and that this whole thing has moved to the right. This is very important because I'm only going to have one rejection region. Okay, so my rejection region is going to be out here. My do not reject is going to be right there. Okay, sorry for the kind of doctor's handwriting. I would really focus on, again, we could say, you know, I mean, let's write another example of an alternative. So if the alternative hypothesis looked like this, okay, then our rejection region would be on the left side of the distribution. Okay. But it's not. So our rejection region is on the right side. This is very important to get comfortable with. Okay. So hopefully I've put it kind of cleanly. Hope is not a plan. All right, cool. So rejection region, do not reject region. All I need is this critical value. And I'm going to compute this, and I'm going to compare the test statistic against that critical value like we did before in our decision rules. And Jenna said, hey, based on our decision rule, we're going to reject. So the fact that we need a critical value should cue us that we're going to go back to our Z-hacks table. So I'm going to do that. Boom. Okay. Z-hacks, I must be in the right place because I'm rolling with Z. Nope, I'm not doing a two-tailed, so I'm going to go over here. One-tailed. My alpha is 0.05 in this case. So now, even though it says plus or minus, for a one-tailed test, I'm only going to have one critical value. So pick one. If I'm on the right side of the distribution, it's going to be positive. If I'm on the negative, if I'm on the left side, it's going to be negative. In this case, I'm on the right side, so it's going to be 1.645. 1.645. I need to remember that. I'm going to get out of here. See you later, cube. Come back over here. Fire this back up. Boom. And that right there is 1.65. I think 645 is what I had on the sheet. Sorry about that. So I'm trying to get ahead of Pearson being Pearson. So 1.645. Okay, super. Compute the value of the test statistic. That's this bad boy. I already know how to compute that. I have all the stuff I need. And because we're doing the same problem multiple times, I know that that's 2.814. All right. So Tyler, do I reject the null hypothesis or do I fail to reject the null hypothesis?
You reject it
Why do you say this?
because it's in our rejection shaded area.
Yeah. Because 2.84 is way more than 1.645. And like Tyler said, it's way out here. So we reject that thing. Okay. And again, the answer to the so what now, as opposed to our two-tail, now we can say, hey, that true, and which brings to a point I want to highlight. Hey, that population proportion is probably a lot greater than 45%. And there's a hefty market there that I want to go target these people, get them recruited, get them in the jobs, so on and so forth. Now, let me digress for just 2 seconds. A very healthy thing to do here would be to develop a confidence interval of what I think the new population proportion is. Okay, I know it's greater than 0.45, but where, what is my butterfly net? What does my interval look like? Okay, so remember, to determine a confidence interval for the proportion of the population, I'm going to take P plus or minus Z and this jobby. Okay, so I could take that 0.52, throw it in here. My Z would not be this Z stat. Do not confuse those things. My Z would be my Z based off of my Mike TV table and the percentage that I want to do the confidence interval. Okay. But I might say 95, but that's different than this 0.05. So once I go into this confidence interval thing, I'm done with the hypothesis test. Okay. I've said, hey, I've rejected the null. I'm driving on with my belief that the proportion population has grown, and therefore I want to understand what it's between. Okay. And out of all this, I'm going to come up with an interval of which probably 0.45 might be in between. Actually, probably, I don't know, 0.52. We know it's going to kind of be around that. It's going to be minus that a little bit and a little bit more. So 0.45, for all we know, might not be in that interval at all. It'd be interesting to see. We'll do more reps on this kind of thing later, but don't just toss that, don't just take your confidence interval formulas and burn them or feed them to your chicken or whatever, because this is very much what you might do in this situation once you've rejected the null, if you do indeed reject the null. Okay, and because we're starting to come to our final time together for tonight, I'm just going to go right into our p-value one tail. Again, no change here in terms of problem between our one tail that we just did. The only change is that this time we're going to do it with a p-value method. Okay, and again, that's not something you have to figure out. That's something I'm going to tell you, hey, I want you to do it this way. So I'm going to move a little bit quick. I apologize for that. This is familiar territory. This is familiar territory. We know that this is going to be greater than. We don't have an equal sign down here. That's going to be less than or equal to. We have that set. Next step, level of significance. We have it, 0.05. Again, I'm going to tell you what level of significance to use. I might ask you a conceptual question. Hey, when would you use a lower value? When would you use a higher value? Remember, we use a higher value when we're not as concerned about being wrong. We lose a lower value when we really want to minimize an error. Okay, and most of the time I see 0.01. All right. I think when people do stuff with a higher level of significance, it's kind of almost like, why bother? But anyway, I digress. N is 400. Appropriate test statistic and sampling distribution, we know. Z distribution, Z stat, P minus this over this. Collect the sample data. We have it. We just need to compute P. We computed the same way we've been doing it. 208 divided by 400 is 0.52. Compute the value of the test statistic. We know what that is. 2.814. Again, I know that because I have values for all these things. Compute the p-value. Okay. Remember, with the p-value, we have one of a couple ways. We can use an Excel function, or we can go to the z-table. All right, let's assume we go to the z-table. We're going to get 0.9975. We know we need to do a 1 minus on that. So we're going to do that. And we're going to get a 0.0025 roughly. And that's going to be our p-value. Notice that we stop there with p-value. We don't multiply it. We don't do anything to it. It's one tail. Okay? It's one tail. And that, again, golly, my pen is possessed. We're talking about like this kind of thing. All right. And then once we have that p-value, we're not in the end zone yet. We could set up our fish. We could set up our p-value, 0.0025, p-value, or excuse me, our level of significance, our alpha, 0.05, which is bigger. This is bigger. Does the alligator eat the fish? All day long. So we reject the null hypothesis. If the p-value is lower than the level of significance, then the null must go, meaning we reject the null hypothesis. Okay? So the main things about the one-tail p-value, again, we go through the process and our steps, everything is the same until we get to computing the p-value. And there we just got to know what we're doing. This 0.9975 is not the p-value. Okay, we have to do a 1 minus. All right. And then we compare that p-value against the level of significance to, quote, make our statistical decision. And as always, I didn't put what's the so what down here, but the most important thing is what do we do now? On any method we use, if we reject the null or if we fail to reject the null, the real question is, okay, so what now? Questions big or small about anything we've talked about? Okay. So as always, I will hang out until everyone is cleared. I will post this video here with probably the next 15 minutes. It always takes a long time to download. Not that I'm making excuses, but that's why the lag. In addition to that, I will post my clean copies of the work so that you can check your notes again and my chicken scratch on the screen, whatever way works best for you, but you have something you can refer back to. And quite honestly, this will be a preview of the way we will roll for the next 2 sessions. Okay. We'll have one problem. We'll alter it a little bit to do those 4 combinations in the 4-pack. And the reason for that, although it might seem kind of redundant, at this point, I mean, D3M is built on repetition. And I think there's actually strength to be gained through that repetition. If there's anything in here that was confusing to you or something that you don't understand, please get hold of me and say, hey, I don't get this part, and we can go back over it. Otherwise, if you don't want to hang out, ask a question, whatever. I look forward to your projects, but most importantly, have a great weekend. Thank you.
I do have a quick question.
Okay.
I just want to make sure that I'm doing like the Way of the Warrior project correctly. Are we just basically doing like a narrative to like the problem that we're creating and then explaining like all the computations that we did and stuff?
Yeah. So if you let me show you something on my screen. Provided it doesn't take me all day to get there. I don't think it will. Maybe it will. Gee whiz. What the heck is up with that? And, you know, I should have talked about this a little bit to everybody. And I don't know. Forgot about it. But what I've seen is that folks kind of like they have a pretty good understanding of what the project is asking for, and they kind of jump in the car and put their foot on the gas. And I'm kind of like, hey, just check out the outline and the standards here on Canvas, and that actually will help guide you. And when I say you, I mean more than just you. I mean anybody. So if you go here on assignments and down here, here we go. So
I've been using that. I just wanted to make sure that I was like understanding it correctly.
Yeah. So, I think, I would actually use these as subheadings in my paper.
Okay.
And I mean, I don't, now I feel kind of goofy because knowing of your writing ability, but let me talk about not you and other folks. So the beauty are just about this format. So here it kind of forces you to give an introduction, right?
Mhm.
And then you're like, oh, now I need to talk about assumptions of the data or assumptions that I had to make to do this project. You know what I
Mhm.
mean?
Yeah.
So that it seems like a small detail, but I think all the submissions I've gotten so far, they don't have the subheadings. And so as a result, things just kind of start to slip like 1 degree off a little bit.
Yeah.
Does that make sense?
Yeah, it does.
In terms of like, but I remember your paper from last year, and I mean, it was very precise, very organized. So when I think about you, this kind of structure is like another like layer of icing on the cake. It's not
Mhm.
unnecessary. It's actually make it pop that much even more. I'm trying to remember if you had subheadings in your value chain paper.
I don't remember if I might have, but I don't
Yeah.
remember for sure if I did or not.
If you didn't, you didn't need them because it was structured that way. I mean, it was tight,
Thank you.
and and that is that's a challenge actually for folks, more than not, is that they just kind of get in the car and they start driving, and they're driving off the road, and they're kind of way over here, and it's like, okay, what were you talking about again? So that's probably a lot more of an answer than what you needed. But I think if you look through this and kind of say, okay, I really have two pages to kind of, within those 2 pages, say what I did.
Yeah.
And am I doing everything the deliverables kind of asking me to do? Am I
Okay.
talking about the assumptions I had to make, particularly if you had to make up data?
Yeah.
Am I discussing the limitations of the data? And then am I really getting into kind of teasing out what the data tells me and what it's not telling me? And then am I kind of finishing my grand finish with, there's a couple ways you could look at it. One is, if I had more time, what would I do again or explore further?
Mhm.
And another way of putting that is, what would I, what could someone else do with this?
Yeah.
You know what I mean? Because you might be like, I don't want any more time to do with this. I'm done with this. Well, right. But what if someone looked at your stuff and said, that's a great idea. I've got more resources. I've got more time. Um, what could they do with it? Because that's actually how research works,
Mhm.
is, good research and analysis brings up more questions than answers. And as long as you can articulate those questions, someone else can take one of those questions and do something with it.
Yeah.
And that's how, unless you're Einstein, how everybody works. Because Einstein's like this guy, he's like such a player. He's like, I don't need all that. I just know how this should be. But the rest of us normal people, you know, the expectation is that quite the opposite, that you're well versed in what's already been done, and you're filling in a gap by using that as the frame, if that makes sense.
Yeah, it does.
So that was probably a really long and unnecessarily long answer to a simple question.
It helps though. It's okay.
So how are you otherwise? How's everything going?
The past like today and yesterday were very stressful, but I think I'm just after break, I'm having a hard time getting back into the routine of everything.
Yeah.
But I'm doing okay.
Yeah. Yeah. Well, I wish you the best with it. I know this is I mean, I can imagine this is really tough for everybody.
Yeah,
So.
for everyone, professors, students, everybody.
Yeah.
Different.
That is true. So I feel like someone took my ice cream away or whatever, you know. I can't eat ice cream, but I feel like someone took my honeycombs away or something like that. So but it is what it is, and you know, we don't have much choice. Just
Yeah.
you know, kind of drive on. So
Just gotta deal with it.
all right, cool. So if you don't have any other questions, I guess I'm gonna sign off.
Yep.
Okay.
I hope you and your family are staying well.
Yeah, thank you. You too. Have a good weekend.
You too. See you next week.
Okay.